Hi guys, welcome to my another video. In this video, I am going to teach you the continuation of gravitation that I have taught you in the last part. The next topic is the gravitational field intensity due to solid sphere. Mass of solid sphere, here the mass of solid sphere is equal to m, and density of sphere is equal to rho, and radius of sphere is equal to capital R, and r is equal to distance of point from center of sphere at which gravitational field intensity has to be found. Now, at any point outside the sphere, r is greater than r. Here the point is outside the sphere and the distance from point to sphere is greater than the radius of the sphere, and Eg outside is equal to gm by r square. Here volume of the sphere is equal to 4 by 3 pi r cube and mass is equal to 4 by 3 pi r square rho. At any point on surface, at any point of, and the next one is at any point on surface. At any point of surface, radius is equal to the distance of point from its center, and then Eg on surface is equal to gm by r square. Here also the same. At any point inside the surface, here we should consider only the sum of the part inside the sphere. Here m dash is equal to mass of sphere, which contributes gravitational field at point P, which is inside sphere. It contributes only at the point where the P is located. Here r is equal to radius of sphere, and m dash is equal to, and the volume of the sphere is equal to 4 by 3 pi r cube into rho, and Eg inside is equal to g m dash by r. Here m dash is equal to 4 by 3 pi r cube into rho. Here if you substitute here g m dash by r square, I have not written it, sorry. Here g m dash by r square, and then if you substitute, we get 4 by 3 pi g rho r. Eg inside is directly proportional to r. At center of solid sphere, r is equal to 0. And then gravitational field intensity due to straight rod. Here m is equal to mass of straight rod and L is equal to length of rod, and lambda is equal to mass per unit length. A is equal to perpendicular distance of point P from rod. Here it's a rod. We need to find here it's a small element dx, and from the center of the rod to dx, the length is x, and here from the one end of the rod to P is, we take the angle between them is alpha in positive direction, and another end to point P, we take it the angle between the line is beta in negative direction. And then okay guys, in this diagram, this is the small element. This small element to point P, the angle between them we take as theta, and then in this direction it is dg cos theta, and in this direction dg sin theta. We know that it is a square root of a square plus x square, and it is x, and it is a. And then gravitational field intensity due small element in dy dg is equal to g lambda by a square plus x square. And the net x component of gravitational field intensity Ex is equal to integral dg cos theta. Net y component of gravitational field intensity Ey is equal to dg sin theta. And then from figure 2, this is the figure 2. From figure 2, tan theta is equal to x by a, x is equal to a tan theta. If we take d by d theta on both sides, d by d theta of dx by d theta is equal to d by d theta of a tan theta. Dx by d theta, we know d by d theta of a tan theta is equal to a secant square theta. Dx by d theta is equal to a secant square theta. Dx is equal to a secant square theta into d theta. And then dx is equal to a secant square into dt theta. Here if we substitute in ex is equal to, we already got ex is equal to ex is equal to dg cos theta. If we substitute there, ex is equal to, we already know dg g lambda dx by a square plus x square and cos theta. Here we get out g lambda, and then 1 by integral g lambda into integral 1 by a square plus x square into a secant square theta. Here we know dx is equal to a secant square theta d theta. Here cos theta is there already, I have not written, sorry. And then 1 by a square plus x square into a secant square theta into d theta g lambda into here a secant square theta by, here we know, see here secant theta is equal to, according to the diagram, secant theta is equal to root of a square plus x square by a secant theta is equal to root of a square plus x square, and then we write it as a by a secant square theta is by a square secant square theta cos theta into d theta. And then ex is equal to g lambda by a, we get a outside, and then it becomes, we take the limits as minus beta into, here according to figure 1 we know that beta is in negative direction, so we take minus beta, and alpha is in positive direction, we take positive alpha, and cos theta into d theta. Ex we can write as g lambda by a into sin theta cos theta d theta is equal to sin theta, and then we take the limits, and then g lambda by a into sin alpha minus sin of minus beta. Ex we get g lambda by a of sin alpha plus sin beta. Here similarly we can write ey is equal to g lambda by a cos beta minus cos alpha. Ex is equal to we know ex is equal to g lambda by a into sin alpha plus sin beta. If rod is having infinite length, if we draw here, if we draw from this end, we get alpha. If we draw from this end, alpha is go on increasing and alpha become pi by 2, and beta also go on increasing downwards and beta becomes pi by 2. If we substitute in ex value, we get ex is equal to 2g lambda by a towards the rod, and we get ey is equal to 0. Then e net is equal to square root of ex square plus ey square. Therefore we get ex is ex square root of ex square get cancelled. Therefore e net is equal to ex. Therefore we can write e net is equal to 2g lambda by a. Okay guys, that's all for today. Thank you for watching my video. If you like my teaching, please like, share, comment and subscribe to my channel, and don't forget to click the bell icon so you will not miss the next part of gravitation.